So this is an update on one of my previous projects. I made a video a while back showing this teleoperation system that I made where you basically move your arm around, your real arm in front of a camera, and then the robotic manipulator copies your motions. Back then though, I had a pretty primitive system. So now I've improved it a lot. Specifically, I've made it a lot more accurate in tracking your arm. Also, you can use it to control the gripper of the arm. But yeah, so here you see how it works. On the left side of the screen, you see the camera. So it says Z mini stereo camera. So on the top, you can see it's the normal view, and then in the bottom left, you can see the depth, which is normalized. And then on the right is just a video of the arm. So as you can see, it follows my arm around. It calculates, unlike my previous version, which just looked at the pixel values of your arm and it wasn't too accurate. Now it actually calculates based on the focal length of the camera. It actually calculates the position of your arm in 3D space. Specifically, first, it uses media pipe, which is just a library for hand detection. It gets, as you can see on the normal camera view, it finds a position for your wrist, then for your thumb and your pointer finger. And it's getting the depth to your wrist, then the depth to your wrist. And by the way, I'm using the depth to the wrist for all three landmarks because I don't think the depth is accurate enough for the thumb and the pointer finger. So for both of those, I'm just using the same depth as the wrist. But target for the arm is just the position of the wrist. So I use its pixel coordinates at its depth to calculate its 3D world position in meters using inverse projection. And then I'm using that as a target position for the arm. So I convert that to a more I convert that to basically the 3D space of the arm, specifically the Z coordinate, rather than being like 2 meters away from the camera. I convert it to something normalized around 0 for the arm. And then I'm using an inverse kinematic system that moves the end of the tip of the manipulator to a target position. And that's done via optimization with PyTorch. So I have a function which calculates the end position of the arm based on the three angles. So the base angle of the arm, the shoulder joint angle, and then the elbow joint angle. And then I'm calculating the distance between that position and the target position that I want to reach. So I'm basically getting an error or a loss. And then I'm just using PyTorch to optimize the three angles of the arms until it reaches that actual position. So I'm just dynamically iterating that optimization in a loop as the program's running. And then the reason I'm getting the positions of my thumb and finger is because then I calculate the distance between them again in 3D world space so that your distance from the camera doesn't affect it. But again, I'm using the depth of my wrist, but they're close enough that it doesn't really matter. But basically I'm getting the distance between my pointer and thumb finger. If it's less than a certain distance, it closes the gripper on the manipulator. And if it's more than a certain distance, it opens. That way, by putting your fingers together or pinching them, you can actually control the gripper. And it's pretty accurate. The arm's a bit shaky due to what I believe are mechanical issues. There's some bolts falling out, and it just shakes. It shakes a lot on its own, even when it's not powered on. So I think I've tried to do smoothing. And I've tried to lower the learning rate, stuff like that, to try to make it. At first, I thought the optimization was jumping around the target value, but I'm pretty sure it's not that from some testing I did. So I think that's a mechanical issue, but I've minimized it as much as possible, so it's definitely usable. Also, I think if you did this on a more stable arm, this is a pretty primitive manipulator, it would be a lot better, but it still is completely usable. Especially once you get used to it, it's really easy to pick up the balls, as you can see in the video, and it's really efficient. My plan for the future with this is to use this teleoperation system to collect a bunch of data of, for example, me picking up these balls, and then I want to put that into a transformer that will basically teach the arm from end to end. So I just feed into the arm an image of what it sees from a camera somewhere. and it's like current joint angles, and then it'll output the next joint angles in order to pick up that ball. So a complete end-to-end system without any intermittent coding, where you just give it an input image and it outputs controls. And I'm going to use a transformer for that so that it's episode based, so that it can find similarities, or it can correlate the images and it has a history of what happened before. So yeah, this was just an update to show progress I've made. It's a lot better than the previous system. In the previous video, you can even see when you move the arm, it's like it doesn't really correlate to your arm movements. Here, it's still, obviously there is a bit of a disconnect because it's not your actual arm, but it feels like the distance you're moving your arm in real life is the distance the arm moves. The only issue is the shakiness, but besides that, it works really well. It's really consistent too, doesn't really break ever. And yeah, thank you for watching.